Hello, everyone. Today we'll be discussing the solution to Cowlibi 2 from the USACO January 2026 Silver Contest. So in this problem, we're given that there's a circle of n cows, and each cow either belongs to Farmer John or to Farmer Nodge. And we don't know the arrangement. Our goal is to find the order of these cows around the circle, as well as which farmer each cow belongs to. But the only piece of information that we're given is each cow tells us whether the cow on her left and her right are belong to Farmer John or to Farmer Nodge. And in addition, Farmer Nodge's cows always lie, and Farmer John's cows always tell the truth. And so our goal is, given the information that each cow tells us, can we reconstruct any valid like arrangement order around the circle and like type and assign a type to each cow? So, for example, if we look at the sample test case, we have there are five cows, and each of the cows tell us the type of the cow on the left and the right. And in the sample output, we're given that one possible solution is the cows can be in order 4, 5, 2, 1, 3. And in that case, the first four cows could be Farmer John's and the last cow could be Farmer Nosh. And we can verify this to make sure that it actually works, right? So for example, the first cow, cow 4, is Farmer John's cow. So she'll always tell the truth. And she said that the cow on her left was Farmer Nodge's and the cow on her right was Farmer John's. And we can verify this is true. So the cow to the left of cow 4 is cow 3 because it again these cows are in a circle, so it wraps around the back. So and cow 3 is indeed Farmer Nodge's cow, and the cow on our right is indeed Farmer John's cow. And now if we look at cow 3, for example, we can see that um cow 3 is Farmer Nodge's cow, so she'll always lie. And we can see that she said both the cows on her left and right were Farmer Nodge's cow, but since she's lying, this means both the cows on her left and right were actually Farmer John's cows. And we see that this is true, right? The cow on her left and the cow on her right are both Farmer John's cows. And so the first thing we can do to sort of simplify the problem is we can represent each cow by just the two characters the cow tells us, right? So the type of the cow on the left and the type of the cow on the right. So we can represent each cow as a string with length 2 consisting of these two characters. And now we can make some observation on what these characters mean. So the first observation we can make is a J always means that two adjacent cows are the same, and N always means they're different. So this is true regardless of whether the cow who like makes like the statement is Farmer John's or Farmer Nodge. So whether or not the cow is lying, this statement is always true. To see that, we can see that if Farmer John's cow says the cow to her left, for example, is J, that means the cow to her left is Farmer John's since she's telling the truth. So those two cows are the same type. Meanwhile, if Farmer Nodge's cow said the cow to her left was J, that means she's lying, and the cow to her left is actually Farmer Nodge's. But either case, like those two cows are still the same type. And similar for N, that means too that those two cows are different types. So now we know that two cows tell us whether they are the same or they're different. We can say that two adjacent cows have to say the same thing about each other, right? So they both cows, if they're adjacent, will either say they're the same or they're different. What this means is essentially the second character of the first cow is equal to the first character of the second cow. So in this case, these two cows can be adjacent because uh, the first cow says the cow on her right is the same as her, and the cow on the right says the cow on the left is the same as her. So these two statements check out. And the same thing can be done if the character is N. So this cow says the cow on her right is different, and this cow says the cow on her left is different. And this matches up. So this allows us to string together like two cows. And now we can think about how we can string together a longer sequence of cows, right? Since we need eventually all n cows to be in a circle together. Um, and the key idea here is to represent this as a graph where each cow, the graph with nodes labeled J and N, and each cow consists of an edge from the first character to the second character. So for example, like for the sample input, we have this graph. We have these five edges, and we can represent it as a graph like this. And the reason how this helps us is because a valid sequence of cows can be represented as a path in this graph. So, for example, if we have the path like crossing edge 1 and then edge 3, this is represented by cow 1 and cow 3. And we can say that cow 1 and cow 3 can be next to each other because the second character of cow 1, which is the endpoint, which is N, is equal to the starting point of cow 3, which is the first character, which is N. So you can see that we can string together a longer sequence of cows. It would just be a longer path in this graph. And now we want to look at this graph and see how can we, by looking at this graph, tell whether it's possible to put all n cows in the circle? So whether it's possible to satisfy like uh um the initial constraints or whether there's no solution. And the observation we can make is that this is possible if and only if there's a cycle that goes through this graph, which goes through every edge exactly once and visits the node n an even number of times. So this is because since all the cows in a circle are in a circle, going through each cow in order, so going in order around the circle would just mean going through the graph and you'd end up back where you started. So this would form a cycle which visits all n edges. And the reason we have to visit n an even number of times is every time we visit the node n, we flip the type of cow, right? Because remember, n represents that like two adjacent cows are different. So if the two adjacent cows share the letter n, that means like the type of the cow is flipped as you go across. So since we end up back where we started, the number of flips we need to make has to be even so that the first cow has the same type after we go around the circle. So with these three conditions, or with these conditions, we can find a solution for the subtask where c equals 0. So if we don't need to print a solution, we just need to print yes or no. This gives us a way to check whether it's possible. So first, what we'll do is we'll count the number of each edges using either like a dictionary or a map. And then there's three things we need to check to verify like this path exists, right? The first thing is if we look at the edges that cross over from j to n or n to j, there must be an equal number of those. Since we have a cycle, we need to end up where we started, so there must be an equal number of edges in both directions. And the graph should also be connected, right? So essentially, if there are edges from j to j and from n to n, then we need a way to get between those edges. So we need at least one jn edge. If there are no jn edges, that means the graph has to be either only like loops from j to j or only loops from n to n. Otherwise, it's not possible to get both j to j and n to n. And finally, to satisfy the condition that we visit n even number of times, the total number of j to n edges and n to n edges must be even. So we can check these three conditions from our map, and from our like frequency map, and we can print yes or no if all three of these conditions are met. And then to solve the full problem, where c equals 1, we need to find a solution, right? We need to print a valid solution. And essentially, we need a strategy that, given this graph, we need to find a cycle which satisfies these conditions. So some things we can notice, we can visit j to j and n to n edges every time since the start and end point are the same. So one solution could be first, we're going to go through all the j to j edges, and then we're going to go from j to n using one of those edges, and then we'll visit all the n to n self-loop edges, and then we'll just be left with nj and jn edges, and we can just loop between those until we run out. And so this is going to use, if the graph satisfies the conditions above, then this is going to use every edge and we'll print a valid solution. However, there is an edge case based on like the case where there are no j to n edges. So in that case, the graph would only consist of like self loops either between j to j or n to n, and we can handle that case separately. And then finally, after we go through all the edges and find a cycle, this tells us the order of the cows around the circle. And now we can just assign like Farmer John or Farmer Nosh to each of these cows based on like the order we visit. So essentially, if there's an n between two adjacent cows, that means they're different. Otherwise, they're the same. So we can say the first cow is Farmer John's, and as we move around the circle, we know that who the next cow belongs to because we know like whether those two adjacent cows are the same or different. And this allows us to fill in the type of each of the cows by moving through this cycle. So now let's see how we could implement this using Python. So first, yeah, we'll read the input, and the first thing we'll do is we'll create a dictionary to store, in this case, a list of all the cows based on like the type of edges, right? So based on like the start, like the left and the right, and there are 4 cases. And then we're gonna write out each of these conditions, right? So first condition is the number of crossing edges has to be equal. So we'll just check that those two are equal. The second condition is that the graph must be connected. So yeah, either this is the equivalent way of stating this condition. Either we have no like self loops, no j to j self loops, no n to n self loops, or if we have both j to j and n to n, that means the number of crossing edges has to be greater than 0. So this checks if the graph is connected. And we also have to check if we visit n an even number of times. which you can check like this. And so now for our c equals 0 subtask, we can just check if all these conditions are true. The answer is yes, and we're done. And otherwise, the answer is no. So now we can implement the solution where uh, we find an uh, like a valid arrangement of cows. So first, we'll create like a list that stores the answer. So we'll store the order of the cows as well as the type of each cow in a circle. Those are the two things we need to print. And we'll also store the current cow type. So as we're moving around the circle, if two adjacent cows are different, we have to flip the cow type. But otherwise, we keep the cow type the same. And this makes sure that we're satisfying all of uh like the constraints based on what each of the cows says. So yeah, here are the two edge cases. So if there are only end-to-end cows, then we can just use we can just loop through all of them and make sure again to flip the type after each because after each time you visit n, we have to flip the type. And then if there are only j to j cows, then we can just do the same thing. This time we don't have to flip because we never visit the node n. And otherwise, if there are both of those, that means there must be a j to n edge by this condition of being connected. So we just implement our strategy. We're going to visit all j to j edges. Then we're going to go from j to n. We're going to visit all n to n edges. And then we're just going to visit the remaining n to j and j to n edges. Yeah, so first we visit all the j to j. And then now we're going across using the first edge from j to n. And then we're going to process all the cows that go from n to n on that self loop. And again, in both these cases, since we're visiting n, we're flipping the cow type. And then now we're going back from n to j. And now we're just left with jn and nj cows. So we can process those in pairs. So we go from jn to nj, and we just keep going until we run out of cows. And again, remember we need to flip the cow type after each n. So after the jn, we'll flip the cow type, but not after moving to node j. And then yeah, at the end we can just print out the answer and like the order and the cow types. And we can test this on our sample test case. So we have and we can verify that we actually get the right answer.